Since the war on cancer began in 1971, more than 14,800,000 Americans have died from some form of the disease. 1,500 die every day. That's 565,000 men, women, and children in 2009 alone. More people will die from cancer in this country in the next 3 years than all the American soldiers who died fighting since the American Revolution.
From 1920 to the present time, we have made little or no progress in the treatment of adult cancers. So a person who gets prostate cancer or breast cancer today will live as long as a person who got it in 1920. No big change. With all the radiation therapy that we began in the 10s and 20s, combination chemotherapy in the 60s, immunotherapy that began in the 70s, PET scans, MRI scans, you name it, billions and billions and billions of research dollars that we've thrown into this whole area of cancer research and treatment, little or no significant progress in the treatment of adult cancers.
They will burn it, they will cut it out, or they'll try to poison it.
Heavy trading today in the biopharma sector.
Blockbuster cancer drug Erbitux racked up nearly $425 million in sales.
You have this entire industry that is not going to just pack up and go away. This is a business.
Over 1 million Americans are diagnosed with a new cancer every year. All these people suddenly plunge into a dark tunnel that will dramatically change their life for many years to come. Faced with an apparently endless chain of medical tests, examinations, second opinions, medications, new tests, surgical operations, support therapies, and follow-up checks, they find themselves at the complete mercy of the disease. While in that tunnel, each patient feeds an immense medical apparatus that employs hundreds of thousands of people and generates millions and millions of dollars for the medical and pharmaceutical industries. From research laboratories to medical schools, from prevention clinics to worldwide drug sales. Today, the cancer medical apparatus is so large and expensive that it needs its patients in order to survive.
Every year, thousands of people reverse a wide spectrum of cancers by going outside the system to seek alternative treatments. As I researched these treatments, I couldn't help but think about my father's doctor. Why didn't he know about these? As I've come to find out, if he did know and recommended an alternative treatment for cancer, he could not only lose his license, but go to jail. Here are the results of a study of every randomized, controlled clinical trial performed in the U.S. between 1990 and 2004, which reported a statistically significant increase in 5-year survival due to the use of chemotherapy. What you see are goose eggs, or near goose eggs, for all of our major cancers. The medical profession generally considers any drug with less than 30% effectiveness to be no better than a placebo. What you see from studies conducted over the last 50 years is that for our major cancers, the effectiveness of conventional treatments is far less than a sugar pill. Our bodies cure cancer every day of our lives, and the difference between prevention and reversal is one of degree, not kind. In fact, the average American has 6 bouts with serious cancers during their lifetimes. That is, they actually reversed serious cancers 6 times in their lives without even knowing it. Those with healthy immune systems don't know about the battle their bodies are waging. Those with weakened immune systems will find out about these battles in the hospital. The foundation of a good immune system is diet. A good diet enables us to reverse cancer every day of our lives.
How does protein intake affect cancer initiation? Our first test was to see whether protein intake affected the enzyme responsible for aflatoxin metabolism. This is a very complex enzyme because it also metabolizes pharmaceuticals and other chemicals, friend or foe to the body. Paradoxically, this enzyme both detoxifies and activates aflatoxin. It is an extraordinary transformation substance. Books and books have been written on its structure and function. At the time we started our research, we hypothesized that the protein we consume alters tumor growth by changing how aflatoxin is metabolized, either made less toxic, perhaps even more toxic. We initially determined whether the amount of protein being consumed could change this enzyme activity. After a series of experiments, the answer was clear. Enzyme activity could be easily modified simply by changing the level of protein intake. Decreasing protein intake, like that done in the original research in India, 20% to 5%, not only greatly decreased enzyme activity, but did so very quickly. What does this mean? Decreasing enzyme activity via low-protein diets implied that less aflatoxin was being transformed into the dangerous aflatoxin metabolite that had the potential to bind and to mutate the DNA. We decided to test this implication. Did a low-protein diet actually decrease the binding of aflatoxin product to DNA, resulting in fewer adducts? An undergraduate student in my lab, Rachel Preston, did the experiment and showed that the lower the protein intake, the lower the amount of aflatoxin DNA adducts. We now had impressive evidence that low protein intake could markedly decrease enzyme activity and prevent dangerous carcinogen binding to DNA. As time passed, we were to learn something really quite remarkable. Almost every time we searched for a way or mechanism by which protein works to produce its effects, we found one. For example, we came to discover that low-protein diets, or their equivalents, reduced tumors by the following mechanisms. Less aflatoxin entered the cell, cells multiplied more slowly, multiple changes occurred within the enzyme complex to reduce its activity, less critical enzymes were synthesized, less aflatoxin DNA adducts were formed.
Here's a graph of cancer cell proliferation versus increasing concentrations of the 11 most common fruits eaten in the United States. They decided to use human liver cancer for this study. If you drip water on these cancer cells as a control, nothing happens, right? They start out powering away at 100% growth, and they keep powering away at 100% growth. And pineapples, pears, and oranges don't do much better. Peaches start pulling away from the pack. At high peach concentrations, cancer cell proliferation drops about 10%, but bananas and grapefruits work about 4 times better, dropping cancer growth rates by about 40%. Red grapes, strawberries, and apples do even better, cutting cancer cell growth up to half at only half the dose. But these 2 fruits are the winners, causing a dramatic drop in cancer proliferation at just tiny doses: lemons and cranberries. So if you look at the effective dose required to suppress liver cancer cell proliferation, apples are more powerful than bananas, but cranberries win the day. And there was no effective dose listed for orange, pear, or pineapple, since they didn't appear to affect this cancer cell growth at all.